Welcome to Chapter 3. So our first lesson in Chapter 3 is solving quadratic functions. Now, if I come across something in this lesson that is an Algebra 1 standard that you need practice on, I will attach Khan Academy videos for that help. Or you can always ask me a couple of questions if you just need some clarification in class. Make sure, though, that you are pausing the video during the self-assessment questions so that you can actually give them an effort, because I am going to be looking for them in your journal. All right, let's get this party started. So, how do we solve quadratic equations? Well, we can do them three ways. We can graph them, we can do it by using square roots, and we can factor them. So, solving a quadratic equation by graphing, so a quadratic equation in one variable is an equation that can be written in the standard form ax squared plus bx plus c equals 0. A root of an equation is a solution of the equation. You can use various methods to solve quadratic equations. So I'm going to pause. I'll come back with the blanks filled in. Oh, I forgot this one. So one thing I want to point out is in these lessons, we're going to talk about x-intercepts. But we are going to call x-intercepts, they could be two different things. Well, let me rephrase that. They can be called two different things, but they all mean the x-intercepts. So one of them is root of a function or of an equation. So if you're asked what are the roots, you're looking for the x-intercepts. Another one that they call it is the zeros, or the zero of a function. So if you're told to find the zeros, you're looking for the x-intercepts. You're told to find the roots, you're looking for the x-intercepts. So when we solve these, every time we get an answer here, we're actually finding the x-intercepts on the graph. All right, so let's move on. So solving equations algebraically. So algebraically is using math instead of graphs. So when you solve quadratic equations using square roots, you can use properties of square roots to write your solutions in different forms. When the radicand, so I know some of y'all are like, what is that? This is your radicand, all right, your square root symbol. When your radicand, let me point an arrow so we know. In the denominator, so if you have a square root in the denominator of a fraction, and it is not a perfect square root, you can multiply this by the appropriate form of 1 to eliminate the radical from the denominator. This process is called rationalizing the denominator. So when we get to this, I'll show you what this means. But essentially what you need to know here, and you can make a note on your paper, is you can't have a square root in the denominator. If you do, you have to get rid of it. So I will show you some ways in this lesson on how you can do that when that comes up. All right, so let's just dive right into solving the equations using square roots. All right, so this is one of those things, if you don't remember how to solve square roots, then you need to watch an extra video. All right, so we are going to solve it using this one. So our goal is to get x by itself. So if we're solving this, how would we get x by itself? If you said add 31 to both sides, you are correct. So we're going to add 31 to both sides. That leaves us with 4x squared equals, and then if we add 49 and 31 together, we get 80. So still want to get x by itself. So in order to do that, we have to divide both sides by 4. And we get x squared equals 20. Here's the thing. We don't want to know what x squared is. We want to know what x is. So in order to find x, we have to take the square root of both sides. So I'm going to show it like this. All right, so in order to find the value of x, we have to find the square root. Well, the square root of x squared is x. the square root of 20. Now, 20 is not a perfect square, so we have to think about some values of 20 that would, not some values, some factors of 20 where 1 is a perfect square. So when you think about 20, what factors come to mind? So like 2 times 10, well, neither one of those are perfect. What's another one? 4 times 5. Oh, 4 is a perfect square, so we could say the square root of 4 times the square root of 5. Well, we can actually find the square root of 4, so this becomes 2 square root of 5. So our answer for x, sorry, I forgot to add something in here for you. So because, remember, when we square a variable, if this was, say, x can be, if I wanted 25, right, I could square 5 to get 25, but I also could square negative 5 and get 25. So because of that, when we are solving these, you have to say that there's a possibility that it's a positive or a negative. So you have to have this plus or minus, all right, because there's a possibility that it was positive, there's a possibility that it was negative, and then just your answer. So instead of writing positive 2 square root of 5 and negative 2 square root of 5, this gives you your answer. So this is your final answer. So there's 2 solutions, positive 2 square root of 5, negative 2 square root of 5. All right, so this next one, it looks very similar. There's just a 0 already here. So let's give it a try. Let's solve it. So what would you do first? Hopefully you said subtract 9. And guys, if you feel like you've got this already, you're welcome to pause the video, try it, and then join back in. So we have 3x squared equals negative 9. And then we're going to divide each side by 3. And we get x squared equals negative 3. So let me ask you a question. Is there any number that you could multiply to itself and get a negative number? That would be no. So in this case, there's no real solution. And yes, the word real is important because we're going to learn later in the chapter about something called imaginary solutions. Not imaginary friends, but imaginary solutions. So the answer would be no real solution. The reason why is because the square of a real number cannot be negative. So the answer for this is no real solution. The reasoning is the square of a real number cannot be negative. All right, let's try the third one here. I know it has your favorite F word in it, but I will show you how to work with that without being scared. Okay. So we can't do anything with inside the parentheses until we get rid of this 2/5. Any fraction times its reciprocal equals 1. So anytime you want to get rid of this, just multiply by its reciprocal. If you forgot what reciprocal is, it's the flip. So 5/2. So if you multiply that, you got to multiply this by 5/2. So we can make that over 1. That way it looks nice and pretty. All right. So we do that because now those cancel each other out. 5 times 2 is 10. 2 times 5 is 10. 10 over 10 is 1. So now we have x plus 3 squared equals 5 times 5 is 25 over 2. And guys, please don't be scared of this fraction. It just means it's not divided yet. That's all it means. All right, so now before we added, but notice here the square was only attached to the x, and this one the square is attached to the parentheses. So that means we have to find the square root of the entire thing. So we're going to take the square root of this side, we're going to take the square root of that side. Now remember, we could have a positive or a negative option. So what this does is it undoes the square, like these basically cancel each other out, leaves it with x plus 3 equals plus or minus the square root of 25, and I'm just going to separate it, and if you notice that that's a perfect square, you'll understand why I separated it. Or we'll see. Anyways, moving on. So we're not quite done because we still have this 3. And we need to get rid of it because we need just x. So just like any other time, we would subtract 3. All right, how do you subtract 3 from a radical? It just hangs out with it. So what do you mean by that, Ms. Gill? It literally looks like this. Minus 3. Okay? So remember at the beginning I told you we can't have a radical here in the denominator. So we need to do what's called rationalizing the denominator. So I'm going to do that down here because we don't need the work down here. So just in case you want to note, this is called rationalizing. What? Oh my gosh, lady. Rationalization. Yeah, I give up. This word. All right. So what that means, we can't have this square root. So if we have 25 over the square root of 2, we can't have this. So what could we multiply to 2 to make it a perfect square? Well, I know the square root of 4 is perfect. And so therefore, if I multiplied this by 2, that would give me 4. So I'm going to multiply this by the square root of 2 because I want 4. So when I work this out, this gives me, I'm going to leave this like this because remember we know that's a perfect square, over square root of 4. Okay, now we can work this out. We know the square root of 25 is 5, can't find the 2, and we know the square root of 4 is 2. So now the radical's in the numerator, not the denominator. Okay, so our final answer is x is equal to plus or minus, let's actually pull that 3 to the front. So minus 3, and you'll see why in just a minute. So minus 3 plus or minus 5 square root of 2 over 2. So this is our answer, but because we have this number here, there's a way to write the solution. So I'm going to do that under here. So these solutions are, so what I'm going to do is break it up, because if you can combine these, then they need to be combined. So that's why I just want you to go ahead and get in the habit of combining them. So if you can combine these, then go ahead and combine them. All right, so we have 1, negative 3, plus 5 square root of 2 over 2. We can't add these together. I'm not going to ask you to, so that would just be one solution. All right, and then our other one would be x equals that negative 3 again, but instead of the positive, we're going to have negative. So minus 5 square root of 2 over 2. All right, so that was 3 different types that you may come across. All right, so I'm going to have you in a moment pause your video so you can do the self-assessment questions. All right, so here are your 2 self-assessment questions. You have an example in your notes just like both of those, so I would like for you to pause your video now, open up your journal, and work these out in your journal. All right, so hopefully you at least got to this part without getting stuck. And if you did get stuck at this part, then let's work together. So we are taking the square root of both sides. All right, I'm just going to move my work to over here. So now we have x is equal to plus or minus, and I'm just going to separate my square roots. Plus or minus the square root of 7 over 2. However, remember we cannot have this in the denominator. So this is 2 again, and we know that if we multiply 2 times itself, it will make it a perfect square. So we're going to multiply both by the square root of 2. And so what does that give us? That gives us x equals plus or minus square root of 14 over the square root of 4. We know that this is a perfect square. We cannot do anything with the 14. So this becomes x equals plus or minus the square root of 14 over 2. So your solutions are positive square root of 14 over 2 and negative square root of 14 over 2. So that's where it would cross the graph on the x-axis. All right, so hopefully you gave number 2 a try. If you didn't, please pause the video and try it now. All right, so hopefully you got to this part. All right, if you got stuck at this part, remember, if it's in parentheses, you have to find the square root like this. But what is going to happen here? We now have x minus 4 squared equals square root of a negative number. Remember, we cannot have a negative square root. We'll learn about what happens with those later. So this would be not no solution, but no real solution, because eventually we're going to learn about an imaginary solution. I think that's in like lesson 3 or 4. Okay, so hopefully you did okay with these. I'm going to start a new video for example 2.